You might be surprised to hear that the moon is actually a very difficult object to orbit around. It has a very lumpy, bumpy gravitational field with lots of mountains and places of higher and lower density, and that any satellite that is trying to orbit the moon at a very low altitude is doomed and will very quickly crash into the surface of the moon without some kind of ongoing propulsion. And that's interesting. So when you think about how, some future version of civilization is going to want to extract resources from the moon and fire them off into space with some kind of electromagnetic gun, that you're going to have to deal with this lumpy, bumpy gravitational well that's constantly trying to bring your cargo back down to the surface of the moon and crash it. But there's actually a way to make this gravitational field work in your favor. And this is the thinking from Dr. Pekka Janhunen. He's a research manager from the Finnish Meteorological Institute. I've reported on Dr. Janhunen many times in the past. One of the ideas that he came up with is this idea of an electromagnetic sail. That instead of using a solar sail where you use the light pressure coming from the sun, you use the solar wind, the charged particles that are coming from the sun, interact with those, and there's a way that you can get a very fast acceleration out into the outer solar system. And this has been considered to be one of the best ideas for being able to go out to the solar gravitational lens, be able to go and fly out into interstellar space, or even just travel around to the more distant parts of the solar system. But Dr. Janhunen has been thinking a lot about the gravity of the moon and how we can extract resources from the surface of the moon. And he calculated that, in fact, there are some optimal places that you can launch payloads from the surface of the moon where they can remain stable around the moon for a relatively long amount of time, like over a week, and that you could then sync up with an existing satellite that's in orbit around the moon. You can try to raise the cargo away and then use it for some other purpose in space. Now, another paper that Dr. Janhunen worked on is the idea of extracting nitrogen from the surface of Ceres. So there are some really interesting sort of far future technology ideas for mankind's future in the solar system. And I think if those kinds of ideas, if you love the expanse, then these are some practical ideas for how we can start living that future expanse lifestyle. All right, enjoy this interview with Dr. Pekka Janhunen. Dr. Janhunen, it's great to talk to you again.
Yeah, it's nice to see you again, Fraser.
I think last time we talked was, you sort of remember it better than I think maybe I did. 7 years ago, maybe you were sort of working on this electromagnetic tether idea, and that's since gone on to have a life of its own. A lot of other papers have incorporated this idea. A lot of people are looking at this as one of the only best viable ways to get out to interstellar space, out to the solar gravitational lens, sort of like the right technology at the right time. Has there been any updates? How's that going for you?
Yes. So this electrostatic sail, electric solar wind sail, as we call it, it's kind of in the pipeline of being commercialized. So there is a startup company whose name is Aurora Propulsion Technologies that is pursuing it. But their business plan is not to do that directly, but they first do the so-called plasma brake, which is the same invention but applied to removing orbital debris, so deorbiting satellites from low Earth orbit. So they are doing that, and they also have another pillar in the company, which is to make small water resistor jets. So that is just to de-risk this activity from the commercial point of view. But then after this plasma brake has been established and the business is going on, then our idea is to pursue this electric solar wind sail and to look into missions that fly at high speed out of the solar system somehow. That is kind of the priority. And I'm kind of semi involved in the company, so I'm their advisor and board member and stuff like that. But my day job is still to be a research manager at the Finnish Meteorological Institute space unit.
And I know after we had talked, I think you or someone in your team had gotten a NASA NIAC grant to investigate the technology as well. So sort of more work has been done on that front.
Yes, the NIAC grant was gotten by people from the Marshall Space Flight Center. So Les Johnson's group, Bruce Whiteman was the guy who actually managed that job, and they kind of made some plasma chamber experiment of that technology. So they tried to measure this, what we call is Coulomb drag effect. We call it Coulomb drag effect. We can also call it electrostatic drag effect. They measured it in a plasma chamber.
And so it's nice to see like a practical test of the theory.
Yes, and we have tried to make CubeSat tests in orbit, but we have had bad luck with these tests. So we have had several tests, but all of them have failed for some kind of unrelated reason. So the last reason was that the CubeSat got stuck in the launch tube, which is a very rare failure mode.
Right. I don't think you can blame the tether on that.
Yeah, I mean, some people say that it's the curse of the Coulomb drag
right.
that has affected the satellite somehow. But no, I mean the tether had no functioning at that point yet. So there were two CubeSats in this series which suffered the same fate. So we were not the only one. So but it's a rare failure mode. I don't remember the similar failure happened earlier, actually.
Right. Well, hopefully we will see a test in space, and then we'll find out exactly what.
Another CubeSat in the pipeline. So it is now. It should fly next year, let's say so. But we don't yet have a launch date. But it definitely should fly next year.
Fantastic. Yeah. All right. Well, let's shift gears then, and we'll talk about the new paper that caught my eye on Archive. And this is sort of your ideas on how we could deliver material from the surface of the moon into low lunar orbit. Why is orbiting the moon actually such a difficult and dangerous prospect?
Well, I mean, there are perhaps more than one reason, but the usual reason is that the lunar gravity field is bumpy. The moon has these mass concentrations or mass cons, which also show up in the complex gravity field of the moon. So typically it is so that if you put a satellite in very low lunar orbit, then it will crash to the lunar surface in relatively soon. I mean, in a matter of months or perhaps even weeks, unless you do continuous orbit maintenance. I mean, unless you use propulsion to correct the orbit all the time.
Yeah, and I know we've seen that. There was a bunch of missions that have been sent to the moon, and they really they can't survive very long in that sort of weird gravitational field with all of these different levels of concentration underneath the surface will make them more and more unstable over time. Is the Earth's gravity also sort of conspiring to make this worse?
Not really. I mean, you mean the Earth's tidal effect?
Or? Yeah.
It has some effect, but I don't think it has very, very great influence on the very lowest lunar orbits that we are talking about now. So then, if you go to higher lunar orbit, then Earth's gravity plays a role, but not for those let's say 50 kilometer altitude or few tens of kilometer altitude orbits that we are now talking about.
And so when we think about spacecraft that have been in orbit around the moon for long periods of time, like Lunar Reconnaissance Orbiter, it is modifying its orbit to maintain stability.
Yes, I mean, but if you apply propulsive corrections, you can basically resolve this problem. So the only drawback is that you consume propellant then.
Right.
But in this present paper, I mean, I guess we are getting to that soon. But I mean, or Is that your next question? That
Yeah. So I mean, I guess the point being that you see these gravitational anomalies on the surface of the moon, you figured out a way to make them work in
yes,
our favor.
yes, exactly. Yes, exactly. So we can ask. I wanted to ask a question that could we somehow utilize this effect or this fact of nature that exists on the moon. So, and I mean, we know that the equation of motion is time symmetrical. So if crashing to lunar surface is a possibility in many cases, then perhaps the reverse process also works under some conditions if we pick the initial conditions properly. And indeed, it turns out that the answer is positive. So yes, we can find orbits around the moon which are such that you can launch the projectile or you can launch the body from a single point on the lunar surface by using, let's say, a gun of some type. Let's call it a gun for brevity. You use a gun to shoot a projectile to an orbit around the moon. In normal case, this projectile would crash. It would basically make one orbit around the moon, and then it would crash again at the point where it was launched or very nearby it. But because of these gravity anomalies, there are certain sites and certain directions where to launch, where this projectile continues to orbit the moon for an extended period of time, such as 1 week. 1 week, which means about 100 orbits around the moon, and only then it crashes. And the idea is that this might give an opportunity to pick up this projectile by an active satellite which uses propulsion. So you can make rendezvous with an active satellite to try and capture this projectile using electric propulsion, which is fuel efficient, which is efficient in terms of propellant consumption. And this might give us a way to lift material from the moon without using chemical propulsion, by just using electric propulsion and some kind of, let's call it gun
Right.
for now.
And so without using this technique, you may have, as you say, a gun, an electromagnetic launcher, a rail gun, a Gauss, there's lots of descriptions, but essentially you're using electricity on the surface of the moon to accelerate a payload to a couple of kilometers per second in velocity that normally, if you can't go into lunar orbit this way, like you're either going to have it crash down on the surface or you're going to go into Earth orbit, I guess, or solar orbit if you go fast enough, right?
Yes, so if you launch at 2.5 kilometers per second or more, then you are escaping from the lunar influence, gravitational sphere of influence, and then you enter basically Earth orbit. But doing such things is kind of challenging from the point of view that well, if the projectile has active propulsion, then you can do this kind of things. But now I wanted to see if it's possible to launch something which can be made completely from lunar resources, so that the projectile would be completely passive and free of any Earth imported materials. So just a piece of glass made of lunar regolith, for example, or any solid material that you can produce completely from the lunar resources. So that was kind of the boundary condition of my thinking.
Right. And so that means like you don't need to have some reusable spacecraft where you put the payload in and then it is launched and then it has its own propulsion system that takes over. The point just being you're putting dumb material, rocks, whatever, hurling it off the moon, and then you've got a week longer to catch it with something that is in orbit and then circularize its orbit or move it off of, or do whatever you need to do with it, that you don't have to get more complicated than that. So to talk about the trajectory then. So how did you go about finding this ideal trajectory, the spot and direction on the moon?
Yes, I mean, first of all, I simplified the problem by just requiring or just by assuming that we are in equatorial orbits, exactly equatorial orbit. And the reason for that is that then the launch window is every orbit of the satellite, so which is about 2 hours. So from the fixed site on the moon, you can launch with your gun. You can launch every 2 hours roughly the payload to rendezvous with the satellite that is also in the equatorial orbit. I mean, if we would use some other inclination, if we would use, for example, polar orbit on the moon, then the problem is that the moon rotates very slowly under this orbit, beneath this orbit, and then you have a launch window only when this satellite passes overhead of your site, which occurs twice a month, basically, every 14 days roughly. Uh, and that is very rare launch window compared to the 2 hours that we can achieve by using equatorial orbit. Okay, so then I just made an exhaustive search of all equatorial sites on the moon. So I just override this longitude parameter and just saw what happens if I launch a projectile eastward from this site. We could also launch westward, but I only considered eastward launches in this paper because then that's kind of the prograde, natural prograde orbit in the Earth Moon system. So most lunar satellites and everything usually follow this prograde orbit rather than retrograde orbit. And then I also primarily, I mean, I found some solutions, maybe 6 or so, and then 3 of them are on the near side of the moon, and the near side is more practical because then we have this can have this continuous radio contact with Earth. But there are also some sites on the far side of the moon.
And I'm trying to understand why. Why does this happen? Why does this work in your favor? Is that it's hitting more lower gravity regions than higher gravity regions, and so it's just able to kind of put off that crash back into the surface?
Yeah, that's a good question. I'm not able to answer that question, so I haven't thought about it so deeply. The only thing I know is that I tested what happens if I reduce the order of the spherical harmonic expansion that I used to model this lunar gravity field. So I first started from this full model, which is 1200. I mean, the degree of the expansion is 1200, which is quite a lot. And then I reduced it, and then it turns out that about 60. So I need about order 60 or maybe 50 terms in this spherical harmonic expansion in order to have this effect more or less faithfully reproduced. So you really need rather many of these lunar gravity anomalies, but you don't need these very small scale details. But I mean, just having the quadrupole or octupole field doesn't that didn't seem to be enough in order to reproduce this effect.
Right, right. And so then, you know, I mean, this is a fun experiment, sort of a fun thought experiment to sort of figure out, is there a way that we can use the bumpy, lumpy gravitational field of the moon to our advantage, as opposed to it just constantly tearing our satellites down from space. But, you know, sort of you have this kind of larger concept of as you say, an electromagnetic gun on the surface of the moon that is firing payloads off into orbit. They're being captured. What is the purpose of that? What sort of future space construction projects could we see being done with that kind of an infrastructure in place?
Yes, that is a good question. So first of the one application is that we could separate oxygen from these lunar regolith, and there has been a process. At least one process has already been demonstrated quite well how to do it. It's this Beth Lomax and colleagues. It's some kind of, I think it was Edinburgh or some UK university, which made this kind of discovery maybe roughly 5 years ago. They have demonstrated how to separate oxygen from the metals and the silicon that the lunar rock is basically made of. I mean, the lunar rock is about 40 or 45% oxygen by weight, so there is a lot of oxygen anywhere in all rocks of the moon. So one could basically use this method to extract oxygen and then sell this oxygen to SpaceX, for example, to Starship, because most of the tankage mass of Starship is liquid oxygen. Of course, they also use methane. That is another question, how to get that. Perhaps we don't get that from the moon, but the methane could just be brought from the Earth in the traditional way, and just being able to get the LOX, the liquid oxygen from ISRU sources would already be a big benefit. And then these metals and silicon, what is the leftover of this thing? It could be, for example, used as a radiation shield for building a habitat in the Earth-Moon Lagrange L5 point, for example. I mean, we need a lot of thickness for radiation shield if we want to shield against the galactic cosmic radiation also.
Yeah, it's interesting. I mean, I know with relatively recent observations from Sophia and other instruments, we know that there are, and the Chinese have found quite a bit of this as well, that there's water enriched in the regolith itself, and that gets you your hydrogen. If you've got your hydrogen, your oxygen, your carbon, then maybe you can manufacture methane, but at the very least you can get water off of the surface of the moon. You've got these metals, titanium, aluminum, iron, but then they could also be, as you say, you could be extracting the oxygen, firing that off into space, and then building roads and structures and stuff out of some of those metals and another material. I mean,
yes, and one thing is that oxygen can also be used as electric propulsion propellant. So that is not. I mean, the technical readiness level is still relatively low of that technology, but there has been successful demonstrations of using air gases for at least for Hall effect thrusters. At least in Europe, the company named Citael in Italy, they have successfully demonstrated that it's in another context, that it's in the RAM-EP, I mean the air-breathing electric propulsion idea, which is a completely different idea. I mean, how to use atmospheric gases for basically like an electric jet engine, which is like a Hall thruster, but doesn't need propellant to go with. But the same thruster technology could also be applied to using oxygen as electric propulsion propellant.
Oh, it's really interesting. Yeah, I did an interview about those air breathing ion engines. It's such a clever idea that you could bring in air, ionize it, move it through an electromagnetic field, and use that to try and maintain your orbit with your satellite in orbiting around the Earth, or maybe Venus or Titan, or any place that has an atmosphere. But what you're saying is that instead of having to take xenon or krypton or some really complicated, expensive, rare, noble gas to space, you could use something that's far more prevalent, like oxygen, which, as you say, what is it, 40% of the rock on the moon, you heat it up and you get that oxygen out, and then now you've got this gas that you can use as a propellant. Maybe it's not as efficient as argon or krypton or whatever, but it is available in enormous amounts. And I think, it's funny when we think about, say, back to Gerard O'Neill and the O'Neill cylinders. I mean, his idea for building these giant space settlements depended on the moon. That they even saw that you needed electromagnetic launchers that were sending material off of the surface of the moon that you could then capture and turn into buildings. Now it shows there's some actual productive places you could put these launchers.
Yes, I mean, this can be seen as a further development or as a brainchild of O'Neill's or pioneering work, of course. So he envisioned using a coil gun or gauze gun, as it is also called. But you can also use other, I mean, there are several technologies that you can use. So there is rail gun, coil gun, then something called quench gun, which is a superconducting system, and then quite ordinary mechanical sling is also one possibility. And then this something called slingatron, which is like a spiral shaped tube, which is somehow moved like this, and then it launches something quickly. So there are several options how you can make a gun type device on the moon without consuming any consumable. So you cannot use ordinary gun because a gun needs air, some gas, and the only gas which is kind of available from lunar resources is oxygen. But oxygen has a speed of sound which is 6 times less than the orbital speed of the moon. So you cannot really, or at least it's very challenging to have like an air gun type launcher on the moon, and therefore these kind of electromagnetic systems. I mean, anything which uses electric power to launch material is kind of more relevant for the moon. And then concerning this water on the moon or volatiles on the moon, that's also, of course, that's the mainstream thing. So people are looking at the polar regions of the moon, how to mine volatiles from there. But that is, of course, an exciting possibility, and this water is certainly valuable. It could be used as a fuel to burn with the oxygen. However, the amount of water on the moon is not, I mean, it's large, but it's not infinitely large. So it's about 100 million tons, or very roughly of that order of magnitude, what is estimated the total resource of water on the moon. And while this sounds a large number, it's actually, in the long term, it's actually limiting. So if we are talking about Starship, if we are talking about colonization of the solar system, we are easily talking about millions of tons of propellant. And then we cannot use 100% of the resource on the moon, so we have to use it sustainably. Perhaps we can use a few percent of it maximum and leave the rest for the future generations. But this idea, what I was envisioning, this slinging the lunar regolith, that's an inexhaustible resource, because you can use any material that exists on the moon, and you don't have to go to the polar regions. You can go to the equatorial regions. You just use the regolith, which exists everywhere on the moon, also in the equator.
Yeah, it's interesting. Like, people talk about these ideas of electromagnetic launchers here on Earth, but the laws of physics, like, you're really running up against the laws of physics on how strong the gravity well is for the Earth, the density of the atmosphere, the kinds of materials that'll be required. Same thing with, say, like space elevators, things like that. People are like, oh, we just need things that haven't been invented. But these ideas suddenly become very practical on the moon and other, lower mass objects in the solar system.
Yes, there is a company which does this kind of sling. Is it a sling launch company or something like that?
Spin
I
launch.
think it's actually called sling launch, and it's very challenging, to say the least, for the Earth, because, for example, just for the reason that the dense atmosphere of the Earth makes it very hard to move something at 26. I mean, at orbital speed, 26 times the speed of sound through the lower atmosphere is almost impossible. But if you apply that technology on the moon, then you need 1.7 kilometers per second of speed, which is about 6 times the speed of sound, roughly.
I mean, I wouldn't be surprised. They have a prototype now that can launch payloads a couple of kilometers into, high 10 kilometers, I think. It's probably already doing 1.7 kilometers per second of velocity. Like, the kinds of prototypes that have been tested out here on Earth would work just fine on the moon.
Yes, I don't know what is the speed, what is their muzzle velocity. So I looked for this information, but I didn't seem to find it easily. So maybe it's not public information. Perhaps I don't
Yeah.
know.
Yeah. But the point being, like, I know, even like if you wanted to build a space elevator, that various fabrics that have been already developed today, things like Kevlar and stuff, they would actually work as your tether on the moon. Like, you don't need to invent some kind of new nanofiber. Like, it's ready to go.
Yes, but the space elevator itself is not practical on the moon, because for the reason that the moon rotates so slowly. So it would be too long, basically. So the
Right.
material science is there basically for such a thing, but the cable would simply be too long from the
Yep.
practical point of view. So I think it's better to use something else than space elevator on the moon, just because the moon rotates so slowly. There are other bodies in the solar system where the space elevator might be relevant, such as the dwarf planet Ceres, which rotates fast once in 9 hours.
Yeah, so this is another paper that you released a couple of years ago, and I didn't interview you for that one, so now we'll catch up. So you were suggesting that Ceres is one of the best places in the solar system to gather resources from. Why is that?
There are many reasons, but the most important reasons is that Ceres has at least some nitrogen, and nitrogen is very critical material for building settlements in the solar system, because the atmosphere of any settlement needs air. I mean, and air always almost necessarily needs nitrogen. So if you try to make an atmosphere without nitrogen, you end up into trouble in some way or another. If you try to use pure oxygen atmosphere, you get an increased fire risk and all other problems. But if you have nitrogen, then you can actually reproduce very Earth-like conditions, not only for people, but also for plants, insects, and animals, which are necessary elements of any kind of closed ecosystem, say space settlement. And nitrogen is a rare resource. We have nitrogen in Earth's atmosphere. We have some nitrogen in Mars' atmosphere. We have some. We have nitrogen also in Venus' atmosphere, and of course Titan. But then on asteroids, it's at least thought to be quite rare, rather rare element. But on Ceres, the current thinking is that there is might be even 1%, about 1% of the mass might be nitrogen in form of ammonia salts.
Do we know why?
Uh, I think the reason is that Ceres has originally formed somewhere in the outer solar system, and it has been somehow migrating to its present location later on in the history of the solar system. But I think there are people who know this thing much better than I do. But this is just my kind of simple understanding of it.
But there is some kind of active cryovolcanist, you know, process that's happening on Ceres that is pushing this ammonia rich salt out onto the surface of the world, that you could just go down with the right equipment and scoop it up, and now you would have this key ingredient for building some kind of, any kind of pressurized human habitat, plant habitat. This is going to be your source of nitrogen. But in your paper you went pretty deep about sort of how you would go about actually extracting this material off the surface of Ceres. So what's your idea?
The idea is basically to have what I call a megasatellite. It's basically a collection of many O'Neill cylinders, but fixed in a rigid frame. So make a lightweight rigid frame where you suspend these cylinders. Many of them are on bearings. So you need bearings. You need, for example, you can use magnetic bearings in order to eliminate friction. Then you spin each of these cylinders, but the megasatellite as a whole does not spin. So it's just in microgravity orbiting Ceres at high orbit. So the gravity environment of that megasatellite is very benign. So you don't have lots of you have only very weak tidal forces, which would tend to break up this megasatellite, and therefore this megasatellite could grow extremely large at the end. So the idea is that you have a growable concept. You can build new. You can add more cylinders as much as you want to the edges. It grows like a city grows on Earth. So you expand the perimeter of the thing. You add more structure, more cylinders, and you don't have to remove the old ones. So this is the idea, and this is so because we humans we would like to have an interconnected world. So we don't like, at least I wouldn't like to to have a restriction that we have lots of cylinders which are all orbiting on their own in some faraway places, and then there is no way to travel between, no efficient way to travel between them. And therefore this megasatellite concept that you can have several cylinders which are like different separate cities, and then there is kind of very easy way to travel between any of these cylinders by using like train like vehicles basically.
And so, like, based on your most recent paper, I mean, the plan is again to use some kind of electromagnetic system to get the cargo off of the surface of Ceres and out into space. Now, have you thought about going back and rerunning your gravitational anomalies, on Ceres to see if similar fast tracks exist?
Well, actually, I think that on Ceres, yes, that's also one idea. But I think that on Ceres, you might be better off just using this gun type thing or a space elevator to go directly to a high orbit of Ceres. Just because I'm thinking that on Ceres the gravity field is so low that it's more feasible to have also logistics back to the surface of Ceres. So you can use rocketry to land on Ceres. So you can bring these reusable thrusters that you need in order to make this orbit circularization burn. You can bring them down to the surface of Ceres. And also because Ceres has a lot of water, so you have plenty of propellant, also water, so you can also use water resistant propulsion. So you basically just a steam rocket. You can use that to correct for the orbit after launching it by this gun type thing from the surface of Ceres. And also, as I said, this space elevator is quite viable, should be quite possible concept on Ceres because it rotates fast and the escape velocity is only 0.5 kilometer per second, if I remember correctly.
Okay, and so you could connect up the space elevator to the orbital ring and have this sort of fast track going to and from the surface of Ceres up to escape velocity.
Yes, something like that, yes. There are lots of variants of it, but yes,
right, of course.
Roughly speaking, something like that, yes.
Yeah, I mean, when you think about humanity's future in the solar system and the kinds of technologies and the kinds of structures that you're envisioning, do you think that we're going to be more interested in living on, say, the surfaces of places like Mars or the moon? Or do you think it's more free floating in space?
I think this free floating in space is a better idea, or what I sometimes call unplanetary living. Unplanetary living. So the reason is that it's more scalable, and even more important reason is that then we can get real 1G gravity, artificial gravity. Because I'm really concerned about Mars that the gravity field is too low for people in the long run. So, and I even see that as an ethical issue, that if there are children growing up on Mars in this low gravity field of Mars, then they might not be capable as adults to migrate back to Earth if they would choose to do so for any reason. So they would be prisoners of planet Mars in that sense, just because of their physiology. Of course, we don't know this. We don't know how the human body responds to this 38% gravity that exists on Mars, but we do know that the human body works very well in 1G gravity, and these free-floating settlements do provide that. And also these free-floating settlements, if we use Ceres, they provide more scalability than Mars. So actually, in the very distant future, it's not impossible that we would have more living space in this megasatellite on Ceres orbit than we ever had on Earth or on any planets of the solar system.
And Ceres is just one asteroid. There are millions, and you can imagine.
Yes, there are millions of asteroids, but actually Ceres is so large bodies, it's about 1,000 kilometers in diameter, that it contains, I have forgotten the exact number, but I think 1/3 of the total mass of the asteroid belt. So these other asteroids are significantly smaller than Ceres. So if we ask what is the most resource-rich body from which, nevertheless, which still has a low enough gravity field that it's still efficient to lift material from it, and which also contains nitrogen, then there is only one answer, and that is Ceres.
Oh, it's a fascinating idea for the future. Now, I reached out to my audience before beginning this interview, asked if anyone had some questions. I got one question from Reverend Keith Carter. Launching mass from the moon is helped by lunar gravity anomalies. Is this procedure like surfing the waves on an ocean?
Not really, because this is easier than surfing the waves of an ocean, because you don't have to, I mean, once you have launched, you don't need any control propulsion after that. So this is
right.
This is simple. You just select the right mountaintop,
right,
and then the eastward direction, and then you just keep on launching from that.
Right. It's as opposed to selecting the right wave, because the waves are different in this case.
Yes, but you can kind of pre-select. If you want to maintain this analogy with surfing, you pre-select the right wave once and for all, and then and
you always start
those
there.
waves are then all forever constant for that mountaintop. What is your magical site where you launch?
Awesome. Well, Dr. Janhunen, thank you so much for taking the time to chat with me today. And I hope, we talk sooner than 7 years. There's so many cool ideas coming out from you that I'm sure won't be that long. Good luck with your research.
Yeah, thanks a lot, Fraser. And it was my pleasure to be in this interview. Thank you once more.
All right. I hope you enjoyed that interview with Dr. Janhunen. I'm going to talk about some other resources that we have available. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, David Gilton, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Berg, Jordan Young, Josh Schultz, Paul Rohrbach, ScienceWorldRecord.org, Spiderswap.io, Stephen Krasaki, Stephen Fowler Munley, and Vlad Chiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. I have spent a lot of time interviewing people about the practical ways that we could achieve some of this science fiction future that books and movies and television has filled our brains with. And, a lot of these ideas that we're trying to face is, what are the ways that we could actually live in space in a sustainable manner? And Dr. Janhunen provided one example. I've also interviewed Dr. Adam Frank about how you could take an asteroid, crunch it up, rotate it, and create this kind of torus in space that would protect you from space radiation. I mentioned that the electromagnetic sail would be a way that you could get out to the solar gravitational lens. If you want to learn more about the solar gravitational lens, I interviewed Dr. Slava Turushev, who is sort of the originator of this idea and what the capabilities of a telescope out at that distance would give us. What about other ways that we could travel at faster velocities, maybe to get out to other star systems? Check out this interview with Andrew Higgins about using different speeds of the solar wind as a way to accelerate your spacecraft out to interstellar velocity. So really, I am fascinated by the kinds of practical ideas that can help us live that science fiction future. All right, we'll see you next time.